This is part 4 in a series of videos in which I'm attempting to repair this PDP11. Now this is part of a larger machine that's used to control a CNC machine, and unfortunately I only have this part of it. I don't have the interface, the panel, console, tape readers, that sort of thing, so it is proving to be a bit of a challenge to repair because it's kind of dependent for its operation on the external hardware that of course I don't have. So I'm having to go through this the hard way and look at it one control line at a time. I won't video most of this, it's fairly tedious, but I thought I'd just go through a single example of the way I'm going about doing this. So the general approach I take is to, rather than looking at it as a complete machine, because obviously it gets very complicated. There are various things in here. There are interface controllers, DACs, you've got the processor itself, you've got the serial interface, and then you have this control logic at the bottom. Now this is obviously a custom machine. You can see there's a lot of wiring. In fact, you probably can't see a lot of the camera bits. You can see just how complex this thing is. So you can see there's a lot of wiring on this. It's all wire wrap stuff, custom made, but it's not as complex as it looks. It's just a pain to work on. Let's move the camera back. So really what we have is a microprocessor. In this case there's also a ROM card. So what we've got is a standard PDP11-3. It's got an HA processor card. This particular unit has a ROM card as well, and that avoids the need to load data from a tape reader or other source every time it's booted up. But it does have a tape reader interface, and that's what I'm currently trying to get to work. The owner does have a paper tape that looks like it's a test program that might be needed to do some of the initialization. It's supposed to be battery backed, but the backup battery long since failed, so it's completely lost all the configuration data. This machine has 2 RAM cards, and part of that is battery backed, but as I say, the battery's failed, so when this boots up there's no initialization information, and being a CNC machine it needs that to work successfully, so I suspect the software is not going to be happy until that program has been run. But to run it we need the tape reader to work. Although I'm driving this through a console, we can't really use that to load the tape. It doesn't, because of the way this works, it's kind of flaky in some ways, that the baud rate changes depending on the mode it goes into, so we can't use one serial interface for everything. It stops working halfway through certain processes. So I want to get the paper tape reader working next, and the way I'm going about this, I've made up a couple of headers, adapters. There's a whole range, I think it's about 10 D-type connectors on this that connect to various parts of the machine. There's one on the side here that you can't currently see that connects to the console. That's the kind of main control console for the overall unit. As I say, I don't have that, but it has some switches on it that switch between various modes, including the TTY mode required for the tape reader. Because I don't have it, I've made up a couple of these that simulate that interface. I've made one for TTY and one for console mode. This saves me having a lot of complex switches on here. I've got it set up at the moment for console, and what I've been doing is trying to figure out why the tape reader won't function. Now, from what I can tell so far, it's driven through one of the interface cards, or at least the 8-bit data goes direct to 8 lines on one of these interface cards, and I can read that data in using the terminal program if I manually access the port that it's connected to. The tape reader is very simple. It seems to I haven't got it, but it seems to consist, from what I gather, of the reader head, which is just an optical head, and a stepper driver, and the way this uses it is it outputs a pulse on one of the pins going to the reader, that steps it onto the next tape location, and then it reads that location and moves on to the next. Unfortunately, this is never giving any pulses out on the stepper output. I don't know exactly how it's supposed to be interconnected. I don't have an interconnect wiring diagram for this, but I suspect it should be driven through one of the two driver boards. There's two of these in this machine. Each has an input and output port, but whichever I try and drive, nothing ever changes on the step pin. So in other words, it won't drive the reader. And because I could in theory simulate the reader using a PIC or something, I can't do that without the step output, because there would be no way to synchronize the data it's providing with this machine. So I need to get this working. So the way I'm going about this, I have this lead connected to the step output that would normally go to the reader. I've got the test meter set for continuity mode, and what I'm going to do is try and figure out where this particular line goes to. So I'll connect one terminal of the meter to that wire. There's an interface card down here which you probably can't see. I'll slow the camera again. Okay, and so what I can do is try and figure out where this is connected to. Now most likely it's going to this bottom one. It's labelled panel interface, but that seems to be kind of a general interface that this machine uses. So all I'm going to do is figure out, or try and test, if it's connected to any of these pins. Looks like we have a candidate down here somewhere. So to that one. So we're connected to that pin. Now that goes to this ribbon cable, this bottom ribbon cable, and that in turn goes through to this card. So I'll raise the camera and then we'll try and trace this connection through to this card. So in theory it's going through to this card somewhere. Without pulling the card out, I can't get access to the underside of this connector. So what I'm going to do is just go across the various ICs. It most likely is controlled through the output of one of these ICs. And again we have a candidate here. Okay, have a look at that. That's a 7408, so that's a quad 2 input AND gate, and that is indeed its output. So okay, so we found where it's supposed to be fed from. The next thing we have to do is figure out if this IC is working. Could be a faulty IC. Now without the rest of the machine here, it might not be driven by anything. And I can't put the boards back in because I can't get to the card. And I can't swap the order of the cards because the machine won't work unless the cards are in the correct locations. I can't easily use a riser because of all the ribbon cables, and without the ribbon cables connected, of course, there is no interface. So it's a bit of a pain working on this, but we'll use the scope and just see if the IC seems to be fundamentally working. So we'll get the scope probe. Okay, I'll power up the PDP. And now we'll check the lines. That's the output, so that's low as we can see, and the two inputs are low as well, so the output is what we would expect. Normally if these fail, you'll see kind of a floating or an odd voltage on them, and they also may get warm, not always, but the voltages on there look correct. So what we'll do now is trace back through and see what's feeding the two inputs to that gate. So we'll go from the first one and try and find out. Okay, so it's fed from an output on that device. That's another input, so we'll go to the other one. And so is that. Okay, so I suspect they're fed from something else. Just trying to find out where these signals are originating that control that particular device. Okay, so it's coming from that, and that's a 7404, so that's a buffer, so that looks quite promising. They're normally a candidate for failure because they quite often buffer the external signals, and the pin we were looking at there was an output pin feeding the 7408 that's controlling the step line going to the reader. So we'll turn back on and we'll test this 7404. Okay, so we'll turn the machine on, and then we'll just go down. The 7404 is just a hex buffer, so all I'm going to do is check firstly that we have power going to it, which we do. I'll just raise the camera so you can see the scope. Sorry if you couldn't see the scope earlier, I forgot I had the camera pointing down. But when I was looking at the 7408, the outputs were all showing as low, so that's and there wasn't any strange voltages, it just looked fine. So now moving on to this 7404, that's the power pin, and that looks fine. Okay, that's the input to the gate that's controlling the 7408 that we just looked at. Power, and that, as I said, you tend to get these intermediate voltages when gates aren't working. That's the input, and the output is low. Okay, what I've got here is a resistor on a flying lead. The other end of this lead is clipped to ground. So if I put the scope onto the output of that gate, the 7404 is an inverting buffer, so if I put this on the input, it should try and pull the input low and the output should go high, and it's moving but only by about half a volt, which is kind of strange. What I'm going to do is turn the PDP off and unplug this cable. It most likely goes somewhere else, so in fact before I do that we'll turn the PDP off and see if we can figure out what's controlling that input, because it might be the fault is on the input, not with the buffer, and then we'll test the buffer itself. Okay, so if we go to there, that's the input we're looking for, and I suspect it's supposed to be driven through one of the two interface cards. So we've got the PDP11-1, which is this one, so nothing on that one, and then the other one's over here. And indeed it is driven from one of the interface cards. Now it shouldn't matter this cable's plugged in because the interface card's not plugged in, but just to be on the safe side I'll unplug the cable anyway. Okay, so that's that cable unplugged, and we'll do the same thing again. I'll power the PDP back up, we'll go back to the output of the 7404, and this time when I connect the resistor to the input of that gate, it should cause the output to go high if that gate's working. And it's going up by about a volt, so we'll check the input level, see what it's doing. Okay, so clearly there's a fault with that device. Okay, so it looks like we found the first faulty device on this board. It's a 7404. So I'll pull the board out, get that device replaced, and see if the machine gets any further. But this is the kind of testing that I do. It's just really methodically and logically following through the various signals. If you try and look at the machine as a complete machine, it does get very confusing, especially one like this that has so many external connections. But if you go through in a logical way, although it's time consuming, you can normally figure out what's going on. The problem with this is not knowing how to drive it. We don't actually know when it's actually working. but I'll take this as far as I can and then send it back to the owner, and hopefully he'll be able to plug it in and it will work. But for now we'll get this device replaced and see if the reader port then works. Okay, I've replaced the offending IC with a socket. We'll put a new device in there. Plug the board back in and repeat the test and see if it's resolved that particular problem. Okay, we'll power the machine back up. It's actually drawing slightly less current, so possibly that's a good indication. We'll monitor the output, drive the input low, and as you can see that is now working the way it's supposed to. So what I'm going to do now is reassemble the machine, put the cards back in. I'll hook it back up to the terminal and see if I can now drive the step output for the reader, and I'll get back on camera once I've got it set up and show you the results. Okay, so that corrected that problem. I can now trigger the step pulse for the tape reader. I still can't run the tape reader properly yet. There's some other issues I need to deal with first. And the next one is I've got a problem with one of the two in-out cards, and there's a stuck bit on it somewhere by the look of it. So I'll just go through how I'm going to go about trying to figure out why it's not working. What I've done to make things a bit easier is I've popped out the ROM card. I don't need that for this testing, and I've swapped over the serial and the in-out card. Normally these would be the other way around. It is important on the PDP that the cards are in the right way round for the software to operate correctly, but I'm going to be driving this manually, so it doesn't really matter here if I swap them over. I've also disconnected the cables that connect to the input and output connections. That's just to make sure I've got nothing tied on here. And so the first thing we're going to do is make sure that with these disconnected that the problem still exists. So what I'll do is I'll just grab a jumper and connect the scope to the output that I believe is stuck, and then we'll look at the terminal program and see if the output is indeed stuck. Now I believe it's the W pin on here. Okay, so that's the yellow trace on the scope. I'll get the PDP powered up. Okay, so that's the PDP powered up. The scope's going to be a bit noisy, of course. So I'll now pull up the terminal in the corner of the screen. And if we look at the terminal, what I'll do now is I'm going to enter the address for this particular card. I'm going to try and write all ones to this particular port, followed by all zeros. This is the out port I'm having problems with, and you'll see the issue when I do this is that we should be able to switch between 1 and 5 sevens and 0, but you'll see that there's a stuck bit. Okay, so you can see that the output did in fact toggle on the scope, so the output went high, but when I try to set it back low again it won't go back low. And also when I read back the port value using the terminal program, you can see it's showing a value of 400 octal, and that is showing that bit 8, which is what I've got this hooked up to, is indeed stuck high. And what I need to do now is figure out why. So I'm lucky I do have the schematic for this card, and it's fairly straightforward. There is a bit of complexity in it because it does have various features for interrupt handling, that sort of thing. But what we're interested in here is this section, which is the in section that reads the data in, and this section is effectively this is a latch for the output, and then we have this section which reads the data back. And the way this works is it reads the input value from the output port. There is no internal latch that it reads, it actually reads the pins, and that's what these are connected to. So what we can be fairly certain of here, at least initially, is that because the output is staying high, the most likely cause of this problem is not in the readback section, because it is reading back a high value for that particular pin. And just to make sure that the output did go low for the other ports, if I change to a different port pin, and we'll do the same test again, so I'll go back to the terminal and I'll type all ones followed by all zeros, and we should see the yellow trace go high and then back low again. So as you can see, the problem is just with that single port, and it is on the output. Now, one of the problems with this particular board is the ICs are not marked, it's not identifying which is which, so I'll have to do a bit of detective work. I'll do that off camera, I won't bore you. What I'm going to do is, I know what this is connected to, so this is connected to the W pin, that's what we're looking at here. All I'm going to do is get the test meter, put one probe at this point, and then just search around on the board to find this device. I suspect the problem is this device, or rather this one. It's bit 8 that we're talking about, which is this bit. It's connected to the W pin, which is I have the white jumper connected to. And the reason I think it's this is because, as I said, if it was the readback, then the output would still be toggling, but it would be reading back the wrong value. But that's not what's happening. It's reading back the correct value, but the output is going high and then not going back low again. So either it's this, or there's something else somewhere that's pulling that high. Now, unfortunately, this is dynamic in that there are active signals going here all the time, so it's a case of setting up the scope so we can capture a particular event. And what we're looking for here really is to capture what happens when the clock signal is applied to the latch, and then see if the output reflects whatever is on the input. So we'll do that first. If it's not that, then we'll follow it back through the card and find out what's going on. So first thing I need to do is figure out what this particular device is, or which one it is on the board, and I'll get a test clip up to it and we'll go from there. Okay, so I've located what I think is the correct device, and I've hooked up the scope. So I'm actually looking here what I think should be a working channel, so we can first check to see what it should be doing. That will give us more information, so we know what we're looking for and what we think is the faulty channel. So pin 5 I've got connected to channel 2 on the scope, so that's the purple trace. I have pin 7, which is the output pin, so pin 5 is the input pin to this latch, pin 7 is the output, and I've got that connected to channel 1 of the scope, so that's yellow, and then the blue trace on the scope I've got connected to the clock line, and the scope is set to trigger on the clock rising edge. So in other words, when a clock pulse is applied to this device, what should happen is the input pin should be transferred to its corresponding output, and we should see whatever's on the input reflected on the output. So we'll do that. I'll try writing all ones to the board, and we'll see what happens. Okay, so we can see what happened here is we have the blue clock pulse, we have the yellow trace reflecting exactly what the status of the purple trace was. So in other words, we transferred the value on the purple input through to the yellow, and that's how it's supposed to work. I'll do it again, and this time it should go from high to low. Okay, and as you can see, we did indeed successfully transfer the low state that was on that pin through to the output. The reason we need to trigger on the clock line, by the way, is if we just try and run this, then that's what we get. So we need to make sure we trigger it in a sensible way, otherwise we won't know what's going on. And so this is where it should get interesting. We'll move the pin monitoring the input from the input that we believe is working to the one we think is faulty. So we need to move this to here, and then we need to monitor the corresponding output pin, which is pin 2. Okay, and I'll do the same thing again. We should see the same results, but I suspect that this is where the fault will lie. So I'll go and try and type in the values and see what happens. Okay, that didn't tell us too much because the line's already stuck high. So I'll now go and try and do the reverse and see if the line goes back down to a low value. Probably help if I triggered the scope. Okay, so we'll try again. This time I'll remember to arm the scope. Okay, well it looks like we've got lucky first time here. The input value we're looking at is on the purple trace, and that does indeed go low, so the correct value is being applied to the input pin. We're getting the clock pin, which is the blue trace, and the value that's on purple, on the purple input at the point where the clock is active, should be transferred through to the output, which is the yellow trace, and as we can see it's stuck high. So it looks like it's this device here that's causing the problem. So I'll get that replaced and we'll try again and see if that's fixed the issue. Okay, I've replaced the device, I've put it in a socket, I've got the scope hooked back up. We'll power up the PDP. I'll set the trigger on the scope and we'll try sending some values to the card and see what it does this time. So as we can see, the trace has indeed gone high, so it's the yellow trace is the output, that's the one we're interested in. So we'll now try and set it back low again, and if you remember it's stuck high before, we couldn't set it back low. So I'll rearm the scope, we'll go back and see if we've cured the problem. Okay, so we can set the output back low again, we couldn't do that before, and also notice on the terminal that the value being read back is now showing us all zeros, and it's not stuck at 400 octal as it was before. So that's another fault rectified. I'll get the cards put back in their correct order and then I'll continue fault finding. But it's just more of the same. It's going through, checking the various registers, make sure they're doing what they're supposed to. and hopefully at the end of the process we'll have a working machine. If this is the sort of thing you want to see more of, then please leave a comment. You might find it a bit tedious, but some people may find it interesting. As I say, if you want to see more of the in-depth testing, then just let me know.